we're here with Dr. Dwayne Hamar. He is the section head for chemistry and toxicology for the Colorado State University Veterinary Diagnostic Laboratories. So thanks for being with us today, Dwayne.
Glad to be here.
Very good. Tell me a little bit about what you do here at the Chemistry and Toxicology Laboratory.
In this laboratory, we analyze various samples from animals, and we do a lot of vitamins and mineral analysis, some toxins, including strychnine, lead, and choline esterase for opium and carbamate.
What types of samples you're receiving from a species standpoint?
We see predominantly serum and liver, two major sample types. We also do what is classified as some environmental samples, which means they're water or feed or something of that type. Then once the samples are prep is all done, then they're analyzed on one of the instruments, usually either HPLC, or which stands for high performance liquid chromatography, or atomic absorption, which is what we do the metals on. On the mineral size, the one that we do the most of is copper.
Okay.
And right now the main sample is small samples from dogs that have accumulated copper, or they want to know whether they have, if that's a problem with their liver disease. And then based on the amount of copper and the histology that's done by the pathologist, the veterinarian determines what kind of treatment. We do each analysis at least once a week. For most of the analysis by the HPLC, they can be done the same day they get started. The mineral analysis, we do everything on a dry weight basis. So they're dried overnight, one night, and then digested. We call it dry ashing. Overnight the next night. So that's actually a 3-day process. This is an atomic absorption spectrophotometer. We use it for most flame analysis and do arsenic and mercury and so forth on it. What it does is suck the sample the liquid up into what is called a nebulizer, and puts it into an atomic spray, and that goes up into the flame, and that extra energy activates the metal, and then it absorbs light at a particular wavelength, and that change in light absorbency is a function then of the concentration of the metal. We do standards, and they have a particular absorption, so then we plot the standard concentration against absorbency, and over a certain concentration range, that's a linear expression, and that's all put in Excel and standard curve made, and then the samples are compared to that standard curve. Once we have the concentration for the sample that's put into the instrument, then all deletion factors and the sample weight is taken into consideration, and then the parts per million of that element is expressed that way, and that's what goes out to the client in the report. We have normal and deficient and toxic values for about everything we do, and so then they can compare what their animal is compared to the normal.